In this lesson, I'm going to explain how static net is configured and works. I'm going to review inside and outside static net with a live demonstration. Static net is a one-to-one mapping of local to global IP address. There are two types of static net. Inside static net, which is the mapping of an inside local or private IP address to an inside global public IP address. In this scenario, the private IP addresses are being hidden from the outside host. The other static net is outside static net. With outside static net, it is the mapping of an outside global public IP address to an outside local private IP address. In this scenario, the real external IP addresses are being hidden from the inside host. The configuration process for inside static net is as follows. We will configure the outside interface with the interface command IPNet outside. We will then configure the inside interface or interfaces with the interface command IPNet inside. And then we can define the mapping of the inside local private IP address to the inside global public IP address with the global command IPNet inside source static inside local inside global IP. I provided a topology with 9 routers, which will be used throughout the lessons of NET. R1, R2, R3, and R4 are all considered outside routers. R6, R7, R8, and R9 are all considered inside routers. R5 will be the router that is performing network address translation. The gig01 interface will be the inside interface. Gig00 will be the outside interface. Every network topology is a /24 network prefix. The routers have full connectivity through static routes to each and every /24 network. Before we start network address translation, I wanted to demonstrate a simple connectivity check that we will be used throughout this lesson. We will first attach to R7 and establish a telnet session to R1. Let's go ahead and log on to R7. And so we will telnet to R1, which is at the 10.123.4.1 IP address. We will log in, and then we will run the command show TCP brief. And that displays the local address, which is the address that this router detects it is, and it will show the foreign address, which is the source address of the packets that it is receiving. So in this case, it is detecting that the IP address establishing this session is coming from 10.78.9.7, which is R7, without any network address translation. We will go ahead and exit out of that session. And I will go ahead and clear that session as well on R1. So now that we've logged in, and I've demonstrated how we can use the command show TCP brief to see the source and destination IP addresses. So now let's configure R5 so that the connections from R7, which comes from the IP address of 10.78.9.7, will appear as if they came from 10.45.1.7. So we'll go back to our routers, and this time we're going to log on to R5. We're going to go into configuration mode. We're then going to go into our interface gig00. This is our outside interface, so we'll type in the command IPNet outside, and then we'll go to interface gig01. This is our inside interface, so we'll give it the command IPNet inside. And now what we need to do is we need to define the static net entry. And so the command syntax for that will be IPNet inside source static and then the inside local IP address, which will be 10.78.9.7 because this is the private IP address, and then the global IP address or the inside global IP address, which is the 10.45.1.7, which is the address that we want this to appear as. Now, the NAT translation table, which is local to R5, can be seen with the command show IPNet translations. Let's go back to R5 and run that command. And we can see that our inside global IP address, which is public, is 10.45.1.7, and the inside local is 10.78.9.7, which is a private IP address. So now that it appears we have our NAT translations configured on R5, let's go reestablish a connectivity test. So we'll log back onto R7, and we'll establish a telnet to the 10.123.4.1, which is R1. Go ahead and log in. and then we'll run the show TCP brief command. Now notice in our output, the local address is 10.123.4.1, which is the local IP address, and then the foreign address is 10.45.1.7, which is the source IP address of all the packets that it is receiving. So right now, R1 is seeing R7 coming across as 10.45.1.7. So let's go ahead and exit out of the session. We'll go ahead and clear it on R1 as well. And now I want to walk you through what actually occurred. So the NAT translation that we just experienced used the following steps. We were on R7, we initiated a telnet session to 10.123.4.1. So using a static route, we were then routed to R6, who then forwarded the packet to R5. Now as traffic entered on R5's gig01 interface, R5 performed a route lookup for the destination IP address, which pointed out of its gig00 interface. R5 is aware that the gig00 interface is an outside NAT interface, and that the gig01 interface is an inside NAT interface, and therefore checks the NAT table for an entry. Only the inside static NAT entry existed for 10.45.17 as the inside global IP address, and 10.78.9.7 as the inside local IP address. So R5 created a dynamic inside NAT entry with the packet's destination of 10.123.4.1 for the outside local and outside global address. R5 then translated or changed the packet source IP address from 10.78.9.7 to 10.45.1.7. The packet was then forwarded off to R4 and then onto R1. Now, R1 recognized that the session was coming as 10.45.1.7, and then R1 transmits a return packet to the 10.45.1.7 address, which as far as it's concerned is on the 10.45.1 network, which is reachable through R4. And that packet is forwarded to R4, and then R4 sends the packet onto the link towards R5 because it is a connected network. So let's connect back to R5 and look at the IPNet translation table again. It might have timed out, so we'll go back to R7 and regenerate some traffic. Okay, we should have network address translation in effect. And now you can see the static entry, as well as you can see the dynamic entry, which shows the outside global and outside local entries, which are dynamic for this TCP flow, which is indicated on the left. Remember that a static NAT entry is a one-to-one mapping between the inside global and the inside local address. As long as the outside devices can route traffic to the inside global IP address, they can use it to reach the inside local device as well. So on R2, we haven't initiated any sessions with R7. So what we want to do is connect from R2 into R7. But instead of connecting on the 10.78.9 network, I want to try connecting on the 10.45.1.7 network. And then once we log in, we'll run the show TCP brief. Do a quick check of the routing table. And the static route is missing, so we'll add that real quick. Now remember, we connected it to the 10.45.1.7, which is R7's inside global IP address. And now when we look at the show TCP brief, we'll see the first session, which is R7 connecting with R1. But now we'll also see the session that's connecting from R2, which is the 10.123.4.2 network. But the local address is the actual 10.78.9.7 address, which is the inside local IP address. Now let's exit out, and then we'll also go back to R7 and exit our connection from R1. Now most network engineers assume that the inside global IP address must reside on the outside network. So in this case, we used the 10.45.1.7 when we mapped it into R7. But the inside global IP address could be an address for a network that does not exist on the NAT router. So if we wanted to, on R5, we can use the IP address of 10.77.77.77 for the inside global IP address. The main thing is we need to make sure that the routers that we're connecting to, which would be R1 and R4 and R2 and R3, all had the appropriate static route to reach R5, which is performing the actual NAT translation and responses for the IP address of 10.77.77.77. So let's go through the process of configuring that. The first step is we need to remove the previous NAT entry on R5. So we'll go back to R5. We've removed the previous NAT entry. We do not have to actually do anything with the actual interfaces though. And I'm going to cheat and just copy and paste and just change the last of the global IP address. So now if we look at the NAT translations, traffic leaving from the inside should look like it's leaving on 10.77.77.77 to any device on the outside. Let's go ahead and establish a connection. Now, I know it's going to fail in advance. The reason is we do not have a route onto R3 for the 10.77.77.77 network, nor do we have one on R4. But I just want to verify the connectivity for you live. So we'll do a telnet to 10.123.4.3, and it's going to hang. Now, if we go back to R3, we do a static route. We can cheat. We can use recursive routing. Hold on, take that route and post it on R4 as well. Now, if we go back to R7 and reinitialize it, we'll have connectivity. Now let's run the command show TCP brief. And now it looks like it's coming from 10.77.77.77, even though that address or subnet is not configured on R5. And now let's talk about outside static NAT configuration. Outside static NAT is configured with the following steps. We will specify the outside interface with the command IPNAT outside, and then we will configure the inside interface with the command IPNAT inside. We will then define the mapping of the outside global public IP address to the outside local private IP address with the command IPNAT outside source static, the outside global IP address, and then the outside local IP address, and then we have the optional add route keyword. Now the router performs a route lookup first for the outside local IP address, and a route must exist for that network to forward packets out of the outside interface before NAT occurs. The optional add route keyword adds the appropriate static route entry automatically. Outside static NAT configuration is not very common and is typically used to overcome the problems caused by duplicate IP or network addresses in a network. So the topology has been reset, so there's no static NAT configurations on R5. Now let's configure our outside static NAT configuration. We will make the configurations on R5 so that any packets from an inside host of R6, R7, R8, or R9 towards the actual IP address of 10.123.4.222 will be sent towards R2 at 10.123.4.2. Now R5 already has the appropriate routes for the 10.123.4.0/24 network, so the add route keyword is not necessary. So let's go ahead and connect into R5. We'll go into configuration mode. We'll then go into our interface gig00. We'll mark that as the IPNAT outside interface. And then we'll go into gig01 and mark that as the IPNAT inside interface. And then we need to configure the outside static NAT configuration. And that command structure is going to be used the IPNAT outside source static, the outside global IP address, followed by the outside local IP address. For the outside global IP address, we'll be using the 10.123.4.2 because that is the globally routed IP address. And then for the outside local IP address, which is what is private to the inside host, is going to be the 10.123.4.222. So let me go ahead and make that configuration. So now that we've made the change, let's look at the IPNAT translation table on R5. And you can see that we have the static mapping of the outside local to the 10.123.4.222 to the outside global of 10.123.4.2. Now let me demonstrate what this actually means. We'll log on to R7, and I want to establish a telnet session to the 10.123.4.222 address. And so this is the outside local IP address that we're establishing a connection to, which is private to the inside host, which will then actually translate to the global outside IP address. So we'll connect into R2, and we'll log in, we'll run the command show TCP brief. Now notice that what we're actually connected to is 10.123.4.2. You do not see the 10.123.4.222 anywhere. The source address is originally R7. It has not been modified. Again, we removed the inside static NAT. And to help visualize this process, what we've actually done is on R2 is the outside global IP address. And then what we've done is we've actually made that look like the outside local IP address on R5. So from the perspective of R7, R8, and R9, when they are trying to get in touch with R2, it is no longer available through the 10.123.4.2 network. It is only available from the 10.123.4.222 network. And this concludes the end of the outside static NAT configuration. And it is also the end of this lesson. Thank you.